Hey guys, so in this video we're going to go through how we can simulate torque and three-point bending using Solidworks, and you can use these for your assignment. So we're going to start off with torque because that's actually the easier of the two, and it will lead into our three-point bending test. So what we're actually trying to do is we're trying to have a simulation where our model is constrained on the bottom and fixed, and then we're going to only use the top surface as a torque plane. We specifically don't want to have the rest of our model affected by the torque force, aside from the results of it being on the plane up top. So we don't want any forces on the side, and for that to actually be done using SolidWorks, we need to create an axis for it to reference instead of trying to place all the force along the entire model. So for us to do that, we're going to go to Insert, Reference Geometry, and then we're going to click on Axis. So we want to make sure that the left side is cylindrical and conical faces. That's the option that we want picked. And then we're going to click on the outer surface of our model, and then you see that there's a yellow line drawn, and that's going to be our reference axis. So now that we have this axis, we can go ahead and do our simulation. So we want to click on New Study up top, click on Static, okay, and now let's try to add the fixtures to the bottom of our model. So let's zoom in just to make sure we get it right. And then we click on the surface and press the OK check mark. So now we just have to add our external load. So we just right click external load, click on torque. And when you have selected the blue box, what we're going to do is just click on the surface of our model and then select the pink box and click on our axis. And now you can see that all of the forces for the torque have been placed on the face and not like something like this, which would happen if you didn't have the axis to reference with. So this is exactly what we want. And then we gotta input what value we want our torque to be. So for an example, we can do 100 Newton meters, and be sure to be careful of what value is actually asked on the assignment, because it probably won't be 100. Click OK. And so, a quick recap, we have created an axis for it to reference. We have fixed the bottom. And then using that reference axis, we have created a plane for our plane-specific torque for our model. And now we can actually run the study up top here. And you'll see a deformation model here. And if you don't see something like this, like a conical shape, you can right click on your results, the specific result you're on, and click on deformed result, and it'll toggle the different shape changes and whatnot that's occurring. So again, the three results here are stress, displacement, and strain. So for stress, it's just newtons per meter square. For displacement, it says URES. So URES is just displacement resultant. And finally, for our strain, it is ESTRN, and that just means equivalent strain. So be sure to describe exactly where along the model you see the different colors and what they actually mean, and just where the most stress is seen along the model. For the displacement, you'll see that striation of colors, and then you'll see some lines occurring for the strain as the model is being twisted because of the torque. And those are some things that you guys could definitely describe, or just at least mention in the submissions that you hand in. So now that we're done with that, it's time for us to do a new simulation for 3-point bending. So 3-point bending is a little bit harder, but we're going to need that reference axis that we created for our torque. So we have that reference axis, and so just as a little map of what we want to do, we want to be able to fix both ends and then have a point where we can place a force on the model and have it bend the model, essentially. So for us to do that, we need to be able to create a point that can be used to have our force placed on. And the way we can do this is by creating a vertex of a variety, or at least 3 different planes. So we want to create a midline plane, a surface plane, and for us to make that surface plane, we need an extra plane that is already given to us. It's going to be one of these 3 planes. So let's first start with that midline. So we go to Insert, Reference Geometry, and Plane, and we're going to click on the top face of our model. You can see it has already projected the plane above it, and so we need to flip that offset. So on the left side there's a box you can check for flip offset, and then we're going to input the halfway mark for our sample. So in my case, this model is 100 millimeters long, and I've already placed the 50 millimeter halfway point. So make sure you just calculate what the halfway point would be using your specified dimensions, and then we're going to click OK. So we have our midline plane. So next we need to make sure we can see one of our already given planes, and in this case let's do the front plane. You just right click on front plane and you click show. We're going to need this plane to restrict or constrain our surface plane that we're going to make. So our last reference is going to be another plane. So insert, reference geometry, and plane. And you can already see it's kind of working with the front plane that we just made. If it's not the case for you guys, make sure one of your references is the front plane. You just click on the box, click on front plane, and there you have it. So our second reference will be the outer surface of our model. And you want to make sure that it is perpendicular to the front plane. It just makes everything a little bit easier. And you can see that it is fully defined, which just means it is constrained as needed, and it's going to be on the surface of our model. So now we can just click OK. Alright, so we have our 3 planes, and we have this little intersection here, which is going to be where our vertex is. So the way that we're going to make that intersection vertex is by going to Insert, and it's going to be on Curve and something called Split Line. So Split Line is going to split our surface into different parts. And we're going to actually not take advantage of the different parts, but we're going to actually take advantage of the point that's created by all the different splits that occur. So when you're selecting the planes, you want to make sure you're on the purple box, or the pink box, and just select all of the planes that are used. There's 3 planes. And then we're going to select the blue box and then click on our outer surface for our model. And that should allow it to create the split lines you can see in the yellow. Make sure that the intersection option is selected and then click OK. And you can see the black lines that split the outer surface into quadrants have been created. So we're going to focus actually on the vertex that is on the same side as our surface plane that we created. This is going to be right here. So now we're going to go to New Study, Static, OK. And then we're going to get our fixtures out of the way here. So go to right click on Fixtures, Fix Geometry, and then we're going to go and zoom in and fix both ends. All right. And then we're going to click OK. And now we gotta add our force. Okay. So we're gonna right click on external load, click on force, and then we're going to select that one vertex again on the same side as the plane that we created. And the reason I say that is because we're going to use this plane as a directional reference. So you can see that the line for the arrow is not quite perpendicular to the surface of the model. So the way that we can fix this is by going to selected direction on the left side, and this is where this plane comes in handy. So we're going to click on plane 10, which is just, if it's not 10 for you guys, it's, you know, just the surface plane that we created. And so you can see it says plane 10 here for the face that we're using as a reference. And then we're going to go to the bottom of the left side and click on normal to plane. So as you can see, let's just make this a better, there we go. As you can see, it is the force is coming out of the surface of the model, and we can fix this by clicking reverse direction. Now in some cases, if you don't do the reverse direction, you might see it on the inside of the model. Just make sure to, if you don't see it on the outside, just check on the inside, make sure it's there. And then again, reverse direction, and then we're gonna give it a value. So I'm just gonna use 150, and again, it won't be 150 for your assignment, so just be careful. And so before we do anything here, actually let's just press OK. Let me just go do a quick recap here. So what we did was we had our reference axis, we created a midline plane, we made sure our front plane was visible. Using the front plane, we created a surface plane, and then after that we used the split lines to make a vertex. And then using that vertex, we put a force on there, made sure it was normal to the front plane, like the surface plane, not the front plane, sorry, the surface plane. And then we also made sure to fix the ends of our sample. So now we have what we need for a 3-point bend. So now we can run this study. Again, you can see the deformation, and this is for the stress. We can zoom in. You see most of the stress is actually localized to the point where the force is bending on the sample or the model. If we go to our displacement, you'll see that there is a little bit more of a color variation and more displacement variation around the area of the sample of the model, in the middle of the model. And finally, with our strain, it's a little bit more localized. So these are just things you want to make sure to keep track of, and to make sure to describe. And it'd be nice, again, to have your deformed model shown in the assignment screenshots and submissions, just to get a good view of the changes that occur on the model. So hopefully this helps with your assignment, and feel free to come into office hours and whatnot if you need help, and good luck on the second assignment.